Hello, everyone. I'm Tomasz Tarczyński. I work at Container Solutions as a cloud-native engineer. And here we work with our clients on their cloud-native transformation. So we do this by bringing the technology, strategy, and culture together with our clients. And I want to talk today about Kubernetes config management landscape. So the plan for this talk is as follows. I will start with introducing config management as a topic. Then we'll go into Kubernetes and see what it changes in this area. Then what is the idea of declarative application management? And then we will jump into the tools landscape itself. So there is this great quote from the authors of Kubernetes. They say, of all the problems we have confronted, the ones over which the most brainpower, ink, and code have been spilled are related to managing configurations. So even by this quote, we can already say that config management as an engineering topic to solve, it's actually really a complex thing to be solved. And even at Google and the team behind Kubernetes, there were many different attempts to solve this. But first, to introduce just config management, what I understand by it. So to me, config management is mainly about infrastructure as code. So it means I would like to codify everything that should happen with my infrastructure, then put it into version control, for example, Git, and treat this repository as a single source of truth that should then drive everything happening to the environment. Traditional tools in this area are things like Puppet, Chef, Ansible. And if we take a look into just brief history of this space, so it all started with CF Engine in 1993. Then there were all the other tools, but what's interesting to me, it's like there is already almost 30 years of accumulated knowledge, different attempts in this area. So the topics, the concepts are not really new, but as we can see, there were new and new generations of tools aiming into config management. And we will see soon what's changed as well here for Kubernetes space. Okay, but what are the main ideas, main concepts that are important to me with config management? So we want tools that are declarative. So I want to describe the desired state, not the individual steps that should be made to achieve my desired config. I want some kind of resource automation. It means if I want, for example, a user account, I should have some level of abstraction. Doesn't matter if it's, let's say, Windows system, Linux system, it should be abstracted away. Then there is DSL, domain-specific languages. So those config management tools tend to use those constrained languages that are limited in scope. Typically, we can work with templates. So if I want to have a piece of configuration, I will be templating it out to put some parameters that I can later change. I would package my code into modules. So this means I can share what I automated with others, either publicly in public repositories or privately within the organization. And then the important concept, code data separation. So I would put my code into those modules, and then I should keep the data driving how it should work exactly separately. And that would be a method for delivering parameters to my code. Okay, so now let's see what changes in this area when we go into Kubernetes. So the most important part about Kubernetes to me, it's that it gives us the control plane that provides us with a declarative API. So with this, I can already declare the desired state of the whole system, of the whole cluster. Then the control plane, it will constantly make sure that the actual state of the cluster will always converge to the desired state. And how do we declare this desired state? Of course, with Kubernetes, it's always YAML. And if we take a look here, we've got a very basic, like the most basic example, how do we deploy a simplest possible application? So I declare a deployment with 2 replicas of Nginx, listening on port 80, and then I expose this with a service to the outside world. But from the config management perspective, what's important, I already used something like 30 lines of YAML to declare this. And actually, this one is an oversimplified example. A real life example, when I follow all the best practices, would mean I would need probably above 100 lines of YAML for a simple application. So to check how much YAML actually we work with Kubernetes, I tried to count this. So this was one real life cluster that I worked with, not a big one, maybe 10 nodes or so. And if we try to count this, all those YAMLs, there were about 50 standard objects, then 50 other custom resource definitions that the team added. And then how many actual objects did we have? It was the team working with this cluster provided about 800 API objects, but then Kubernetes, it generates more and more objects based on what we provide. And there are some internal objects. So altogether, there were about 5,000 of those. And then how many lines of YAML? What the team provided was 100,000 lines of YAML. And altogether in this cluster was about 500,000. And typically, you would work with not just one cluster, but a few of those. So we can safely say that we now work with millions lines of YAML. So yeah, there was this quote, like Bob Walker at Config Management Camp asked, are we all YAML engineers now? And he then described Kubernetes as it being a system for YAML that generates more YAML, as you could see in my example. And of course, he answered, yes, we are all YAML engineers now. And then let's take a short look into the idea of declarative application management. So there is this article by Bryan Grant, one of the authors of Kubernetes, called Declarative Application Management in Kubernetes. And he talks there about the central idea of having not just one tool for managing configuration, but rather a tool set of composable tools that we can glue together to manipulate configuration data. And it should all work with the declarative data model of Kubernetes. So what he argues is that rather than thinking configuration as code, maybe we should rather think about configuration as data. So it means with Kubernetes, we can think, let code go into the controllers, the control loop inside the cluster, and then we use data to drive this using the native Kubernetes API format. So if we compare this with the traditional config management tools, I would say that the idea of declarative way of working with configs, we already have Kubernetes API that provides us with that. Then the resource automation is already done by Kubernetes controllers. This idea of code data separation I talked about, to me, it's this divide between controllers and API. And then we've got the 3 other areas. So the DSL templates and modules that are not really covered by Kubernetes itself, but this would be the areas that we are interested to solve with some additional tools that we will dive into in a minute. So with having this preparation, let's now jump into the tools landscape itself. First, again, it's by Bryan Grant. So he created this list of all the config management tools out there that are targeting Kubernetes. And he listed something like above 120 of those. What it tells us, I would say, basically we can tell that as it is such a huge list and it is constantly growing, actually, that it's probably not a solved problem yet. Like, this is area that is really evolving fast. But let's see the current state and what's the most interesting for today. First, just a few words about what possible approaches to config are possible. So the first, like the most basic possible approach is just to fork our configuration. It means I would have some number of configs, then I will copy them, make some changes, and I'm done. Of course, it's a basic approach and it doesn't scale well because having more and more copies, more and more environments, it would be not a good solution. Then we can have a bit more advanced idea, so we can do overlay or patch. It means I have the original config, and then on top of it, I put some overlay. So I override just some parameters, like with a typical patch to a text file, let's say. Then parameterization, it's the typical thing that happens when you use templates. So you have a base config, and then you define some parameters within it. Generation means you write code that generates configs. You can think about this like those Kubernetes generators. So if I say kubectl run nginx, what I do is basically run a generator that creates a YAML object for me and runs on the cluster. So it would be an idea like this. And then we've got two possible approaches to how we codify it. It could either be DSL, so the domain-specific languages, those really constrained to specific purpose. And then it could also be general purpose languages, standard languages like Python, Go, JavaScript. Okay, so having this background, let's now jump into the tools themselves. I will talk about something like 12 different tools, but we'll go through them only really briefly. So the first three are the most widely used tools. We've got JSON at Helm and Customize here. I've put dates when the tools were created and also number of GitHub stars as a way to gauge the popularity of a given tool. So JSONnet. JSONnet is the oldest tool around. It was created by Google, and it's described as data templating language. It's a DSL approach. What's interesting about it is that it is a superset of JSON and created strictly for the purpose of generating JSON. So what it means, you can put just a simple valid JSON file and it would be already a valid JSONnet program, let's say, but then you can add more and more logic into it using different programming constructs that are possible there. What's also important here, that this language is a hermetic, side effect free. It means it doesn't matter, it never matters what's in the environment of your program. It would always, really always provide the same results. The next one, and actually the most popular about all those tools, is Helm. So the Helm approach is to template YAML. So you will use Go template for this. It will let you package your configs into charts, so you can package your code and then publish it either publicly in the public artifact repository, or you can do this also within private repositories within your organizations. Then Helm lets you also manage the releases of your configs within the Kubernetes clusters. So it not only generates those configs, but also manage the configuration state within the cluster. So it can do things like upgrades, rollbacks, and track the state of it. Then Kustomize. Kustomize is also a very popular tool, and it's way simpler approach. So it's template free and DSL free. You actually work only with plain YAML. So the idea here is this overlay or patch approach. So with Kustomize, you will have your base configuration, base YAMLs that are already a valid Kubernetes configuration. And then you will create some overlay on top of it to basically modify your base configs. What's also interesting, Kustomize, it's already built into kubectl. So if you work with Kubernetes, you already have it available. Then the next category are the GitOps tools. We've got two different tools here, FluxCD and ArgoCD. So the main idea about the GitOps tools is to store all of your configuration within the source code repository within Git, and then to have an operator within your Kubernetes cluster that will constantly synchronize the state you defined in Git with the state of configuration in your cluster. So it is all about this declarative approach, actually. Both tools do quite similar things. Both can also integrate with other tools. So from FluxCD, you can work, or for both actually, you can work with Helm and Kustomize. Then ArgoCD additionally integrates with JSONnet. And actually, both of them you can integrate with pretty much any other tool, because as soon as you can get a YAML representation of your config, you can put it into Git, and then the GitOps tools will take it from there. The next category, a few different tools, the newer tools, and they are trying a bit different approaches. So first is Kapitan. Kapitan, it uses two different ideas together. So first is to have a template engine. So it would be about templating, but it allows a few different options here. So you can use JSONnet, you can use Helm, or even Jinja 2 templates. And then it adds inventory for this. So inventory is basically for providing parameters for your templates. It's a YAML-based hierarchical kind of a database. So you can do things like, I want, let's say, 2 replicas on my integration environments, but I want 5 replicas in production. And then let's say I have 2 different production environments. So I would like to have some special labels for one of those, let's say. I think I can make a hierarchy of those parameters in this inventory. And then Kapitan will allow me to join those two together to compile my Kubernetes manifest based on templates and parameters and store those in Git. And then, of course, I would use some GitOps tools to take it from there. The next one is Tanka. It is created by Grafana Labs. It's powered by JSONnet. So we use the same JSONnet language here, but it provides some improvements, some additional value for us. So it provides a JSONnet Kubernetes library. It's a library that let me make very short, simple code to do common Kubernetes tasks. as for example, I will want deployment and a service, so there is a function for that. It was created as replacement for KSONet. KSONet was an earlier project in the same area, but discontinued. And it can also integrate with Helm and customize. And yet another one, kept. This tool is also from the team at Google. So it's very much about this approach of treating configuration as data. So it's all about moving data from one function to another. Those functions would be just containerized small pieces of software that will be used for things like generating, transforming, validation my configs. I can put different things into those functions. For example, there are ready-made integrations with things like customize or Helm. So there are already functions for that. And I can actually integrate it with pretty much anything else as well, just by creating yet another function in a container. So it's like about having this pipeline of different functions manipulating configs and then delivering this to the cluster or to the Git repository. Okay, yet one more category. So two more very new tools here. YTT, it's very similar to JSONet. So it's a DSL approach. What's different from JSONet, it's conceptually close to it, but it, rather than working on the base of JSON, it is based on YAML. So the base idea here, it's like, let's use YAML and then add some method of adding code and logic into YAML. So they done this by putting all the code into YAML comments, actually. It's compared to other approaches, it's YAML structure aware. So it will always provide you with the valid YAML. And it also supports this patch overlay approach, similar to customize. The next one is Q. It is described as a data constraint language. So it's also the superset of JSON, but this data constraint language is like you will work with having just a very base definition of your JSON data, and then you would make more and more concise definitions to go down to your very specific exact configuration that you want to have. It can be used to different purposes like data validation or reducing boilerplate. And now the last category that we have here. So those are the infrastructure as code tools. We've got 3 different things here. So let's see. So if we already use Terraform for defining all of our infrastructure, it is also possible to use Terraform for defining what should happen within the Kubernetes cluster. With Terraform, we work with HCL, HashiCorp configuration language, which is also JSON compatible. So a valid JSON is also a valid HCL. It is a really declarative approach. What's interesting here, you can choose between a few different providers when working with Terraform with Kubernetes. So there is the default Kubernetes provider that lets you work with the core resource types. Then there is Kubernetes Alpha that will let you work with any resource out there, including all the CRDs that you may have. And then there is Helm provider that will let you manage your Helm releases within your cluster. Another tool in this area is Pulumi, very similar to Terraform, so very much for the defining infrastructure. But how they describe this is infrastructure as code SDK. The main difference from Terraform is that you will use general purpose languages here. So it could be JavaScript, TypeScript, Go, Python, things like that. It can integrate with different tools out there like Helm or Customize, and you can also work with just plain YAML. And yet another, the last one here is CDK8. It's from AWS, and it's described as similar to this CDK Cloud Development Kit from AWS, but this one strictly for Kubernetes. It will let you use, again, general purpose programming languages for defining your Kubernetes configs. It supports also integrations with Helm and also with just plain YAML. So that would be it, walking very quickly through many different tools. And now let's just look into a very short summary of what we've seen. So from those tools, there are the two interesting patterns that I would like to highlight. First is that we have this first category of the three most popular tools, JSON, Helm, and Customize. And then what we can see that pretty much all the other tools will let you integrate with those first three. Actually, Helm is the most popular around, and it is like the de facto standard for working with Kubernetes configs. So if you take any project out there targeting Kubernetes, most probably you will already find a ready-made Helm chart for that. Okay, and the other pattern here is what you do with the resulting configuration, resulting YAMLs. There are two possible approaches. First is when you have your resulting YAML, you can just store it in Git and then let the GitOps tools to take it from there and synchronize your cluster. And the other approach is that your tool will apply those YAMLs straight into your cluster. So different tools support different options here. And I tried to give you some picture of what tools are like. The tools up there on this graph are the more popular, so they have more GitHub stars. And then tools to the right are the longer time around. So as you can see, like Helm being the most popular and already above 5 years around. And then we've got a few other tools that are as well quite popular, as well as also being around for some time already. So those would be the safe choices, I would say. But yeah, then if we take a look into yet another summary, let's say, so there was this CNCF technology radar. So what they did, it was a survey between the Kubernetes and user community, and they asked them what they advise to use to adopt. And the users tend to say that tools mostly advised to adopt are Flux and Helm. Then something really worth trying is Customize. And this third category is something to assess, to experiment with, Argo CD and JSONnet. If you are interested in the very detailed results from this survey, here you've got all the answers, but it's pretty much the same as on the previous picture. And and that would be pretty much it from me. Here you've got all the materials I used in this talk. I will share the slides later as well, so you can take a look into that as well. And that's it from my side. And I'm happy to take questions if there are any. Thank you.